Okay, we have another great example now of how to find a line of regression. What I'll do is first I'll read the question, then we'll go into Desmos and work on entering the data to get our line. The following table shows the average annual income in a certain country, adjusted for inflation for a given year. And we have data. Now, notice in this case that we have one of those aligning the data situations where we have years since 1980. So 5 would be 1985 and all that good stuff. Also, as a result, notice this is one of the times that on the left, you have numbers that are not 1, 2, 3, 4, 5. Keep that in mind when you're putting the numbers in, because a very common mistake is to just use, a basic counting system. Sometimes they look like they're in fives and one of them is like 27 or a number that's off. So always look closely at that. Even if it looks like a pattern, just keep your eye out for that. Let's open up Desmos and let's go in and get a table ready by pressing the plus sign first and then select table. Now I'm going to go in and first I'll enter all the X numbers. The X numbers, after a very close look here, they are certainly 0 through 30 inclusive at jumps of 5. So let me put it in that way: 0, 5, 10. And as you can see, Desmos knows and hypothesizes what you want. So just go ahead and go all the way. There you go. How many of them were there? Up to 30. I gave too many. Okay, so this one is in here. This one is in here. This one is in here. Okay, good. Let's go in and now put the other values. I have, and they're a little bit complicated, so I want to do them one at a time. 23, 109. 23016, 25384, 15 is going to be 26694, because every so often you have to check and make sure you're looking at the right value. It's 26694 for that one. 3719. 3350, and then last 28938. Okay. Now, when you do put your syntax in here and you ask Desmos to figure out the those parameters for your line, if you're slightly off and a very little typo happened, like for example, if you were here and you accidentally put in 30530 or something human like that, what'll happen is, I mean, these are to the 100th and 1000th place, these parameters that the utility is giving you. So it will affect it. And often when students try to do this and they don't get it right, it's because there's a very slight, little, tiny typo. So that's why when you put data in for this purpose, you have to be very attentive to what you're typing and very careful. That's why, as you saw, it may have been a little bit drawn out, but you have to recite in your mind each of these numbers, 23109, and type it in very carefully, each one. And if you're doing that and doing something else at the same time, there is a chance that you might make a mistake. So I just want to reiterate, that's really the key to doing well on these kinds of problems, is close attention to very small details like that. So now let's go ahead and type in here our syntax. Y1 is going to be similar to, remember that tilde that's on the left of the one up there, okay? The parameter m, and then x1 plus, and then the parameter b, representing the intercept. So m is our slope, b is the intercept. As you can see, this is a very complicated looking expression here. It's going to be y equals 267.786 x plus 2870.4. You can get a look at the data if you want. You could play with the wrench and get it. It's way up. I mean, but you don't need to look at it to be able to do it. There is a visual presentation here of it. You'd have to change it with the wrench, which is not hard to do. Let's just do that for a minute. You'd have to change it, make the x-axis go from, you can see the values go from 0 to 30, so make it go from 0, maybe a little behind 0, maybe -10 to 40. And on the y-axis, it's going from 23 grand to 28 grand. So make the y-axis go maybe 23,000 to 29,000. See, now you would really get a chance to see all the dots. Look, now you have a good picture of all the dots. There they are. But the other thing about it is you don't really even need to see that. That's not even what's really important. What's important is that the data are accurate and that you put in the right syntax so that you're able to construct the answer. Now look at what the answer is. Very complicated. And I could see that this student did a very good job and got very, very close, but was only slightly off. In fact, I think what happened was in this case, there was it says round the regression line to 2 decimal points. It might be that that's why it's incorrect, because actually I would say this student got this correct. It looks accurate. The only thing that is incorrect is if it's a 2 decimal points, 8, 6 here, you know that should become a 9, and that's probably why WebAssign said no, that's wrong. And this is part of what I'm saying with these exercises, is not only attention to detail with those numbers, but if it says 2 decimal places, now you have to remember the rules of rounding. You know, if you have 8, 6, you have to make sure that 6 is a number that's 5 or above over there, dictates that this 8 goes up to 9. If you remember all that stuff from back in middle school, I think is when we learned about rounding. So that's the answer to part A. I hope that helps a little bit. And as you can see, the numbers here are what we did see for the answers in Desmos. So we have that. Let's take a look now at part B. It says plot the data along the regression line, along with the regression line. So notice that this picture, and this is something that I think is really important when you guys are trying to get these questions right on the exams. You'll notice that right here, the y-axis has a label of 10,000s going up from 0 to 40,000. And then going to the right, it's going from 0 up to 50 here. That is really important to note because, and look, is it like that in all of them? Make sure, check to see if it's like that in all of them or not. It looks like it's the same there. It looks like it's the same here too. It's the same every time. So if it's like that, then we're telling you what to put in the wrench. The wrench is supposed to have over here going from 0 to 40 grand, like that. And then over here for the x-axis, the wrench should look like this. It should go from 0 to 50. I'm getting that because I'm looking at the actual axes. So let's go back into Desmos and change our view of Desmos so that with the wrench, we're looking at an x value range of 0 to 50 and a y value range of 0 to 40,000. All right, so we'll go in over there and do that. I'm going to get rid of this writing now so that we can see. And I'm going to change it with the wrench. And I'm going to make it that on the x-axis, it goes from 0 to 50. And then on the y-axis, it's going from 0 to 40,000. Now, doesn't that look a little bit more like some of the multiple choice questions that we saw there? It looks almost identical to some of them, really. Take a close look, try to remember it, and look again here. Doesn't it look kind of like that? I don't think it's this one here. Let me zoom out a little bit so that you can see them all. That's a little bit better here. Here we go. Now you can see them all. So if you compare and contrast them, looking at them, okay. Sorry, I just want to get a good view for us. There you go. If you compare and contrast them, I would say it's probably got to be one of these two. It can't be one of these two, right? How do I know the difference between those two? Well, one thing I'm looking very closely to notice is notice the intercept here is, look at where it is, the intercept. And here, look, the intercept is almost right on 20,000. So now let's look over here again at our graph. You see where the intercept is? The intercept in this case is right here. So it's between 20,000 and 30,000. See that? That's why the answer is going to be here, and it is here. Give it a star. See? That's what that little key means, of course, is that's the correct answer to this question, and that is the right answer. So how would you figure out which of the graphs to select? First, you have to go in and check the wrench and make sure the wrench matches the axes labels. Then after you do that, then try to weed out which ones are and aren't. For example, you could tell the two on the right I gave green checks to have positive slopes. The others are going down. So that's not them. It's got to be one of these two. Then the only difference I could tell really is where the intercept goes through, and that gave it away when I looked at the Desmos again. So it is really a close matching of the graphing utility versus looking at the assessment tool to make sure you're able to see what the graph is you want. And it's like just it's just figuring it out. You have to keep looking at it, and well, if it's this, then it means that, and so on. So that's how you would do that part of the question. All right. And then there is another piece to this question. Let's finish it. It says down here, explain in practical terms the meaning of the slope of the regression equation. The slope of the regression line is what? It's this many dollars per year. And the slope means that from 1980 on, the average annual income grew by that very amount each year. So this is something that has to do with a margin in business. It's the slope is M equals because of the concept of marginal values. If you do one more sale, or you have one more cost variable, or one more thing increases the whole function by how much. If I sell one more item, how much does the general revenue increase by just one item? And the answer is the slope. The slope is that very answer. If just for one thing happening, it will happen by a magnitude of the slope, and it's the idea of a margin. So the point is, there's a couple ways to say it. You could say the slope is 267.79. If it grew by each 1 year, every single 1 year that goes by, again, it's that number, the slope, because of the number one year each one. So that comes up over and over again in WebAssembly. When you're doing your questions, you'll see a formatted fill in the blank question like C that demonstrates that lesson of how the slope is a representative of the margin, such that if you just make one more sale, or in this case, do just one more income or one more year, then the income will jump by just this much on average. And remember, it is on average because it's based on a line of best fit, not data that are perfectly already linear. So in that one, the answer for part C is insert the slope in both of those places to show that you understand that concept of a marginal value. And then for part D, the last part, it says during which year, since 1990, was income much lower than it would be expected to be from the regression model. So for that, what I'll do is I'll look at the answer here, and I'll also look at the answer in Desmos. We know that this is the correct answer. I'm zooming in so that we can get a good picture of it. We know this is the correct answer. I'm going to say it appears to me that right here, this dot is much lower than the line, than any other dot in relation to the line. Let me repeat that one more time, okay? The dot itself, which is the actual answer of what happened at 30 on the X, is lower than the average of where it should have happened based on the general placement of all the other dots. And that's why we would say it's more of a distance, change color, than this distance here. It's more of a distance than the green distance. That's why I'd say that's the lowest. And if you think about where that would be, that dot goes right to 30, goes straight to 30. I think it's at X equals 30. So let's look at what the answer would be. Right, so if it's 1990, it's getting 210. You know what? Oh, there's a typo there. Look at that. Do you guys see that? I want to show you something. Take a look right here. This does say years since 1980 right here. That says years since 1980. There's a typo here. It says years since 1990 here. It's supposed to say years since 1980. If it did say years since 1980, and I will make a mention of it, I'll send them a note about changing the question. If it said 1980, the answer would be 30, and 30 plus 1980 is 210. And here I think you can see 210 is the answer right there. Okay, so that's how you would go through a question like this. If you ever find any kind of mistake like that or notice something like that, please let me know. Or you can do it yourself. You can report it to WebAssign and Cengage yourself. That's a typo. I'm going to send them a message about it. But that's how you would do a question like this. And as you can see, it really is just the same idea with applications and enrichment on top of it, of how you can apply something like that. Here are some dots. What would the line be? All right. Let's see. We do have another question. Let's go and get that question. We have another great example of using data and getting a line of best fit with Desmos. Here, this question came through. It's a study by Hori compared the dry weight B of brown rice with the dry weight W of the whole crop, including stems and roots. These data in tons per hectare for a variety of this grown Nippon bear grown in various. I'm sorry, I'm stumbling over the words, guys. Sorry. For the variety and grown in various environmental conditions are partially represented by the table. Blah, 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 blah. It's a mouthful. Here's some data. Okay, so let's take the data and now find an approximate linear model for B as a function of W. Now, one thing I have to really jump on here is we like to use X and Y. You have to be really on top of the letters they're picking. And this is math models. It's about representation with different models and variables. So that capital W and that B of W is like F of X, but they're different letters and it's not a big deal. They're also on top of things like capital versus lowercase w. And if you don't put it in, it will mark it wrong. In the same way, it's so sensitive about other things too. So you just want to kind of watch out for that. Something else that's crucial here is it says round the regression line parameters to 5 decimal places. Now that's really a very long amount of numbers, but if you do it right, it will come out right. You'll get it right. But just you have to really watch that structure to get these right. Okay. Now, that being said, I just want to make a genuine mention that when you do take my exam through WebAssign, and if it marks you wrong because of a slight rounding error or 4 decimal places instead of 5 or something, and it's right, I will go in and give you the credit. So I don't want people to feel panicked or nervous taking my exam because of things like that. I'm not here to measure your ability to do rounding or place value or any of those things. You know, we're here to learn something bigger than that. So, you know, just know that, you know, don't let that be a source of stress when you're doing assessments. And if you do see something like that, please speak up and let me know, and I will give you the credit back for mistakes that might arise as a result of all that delicate stuff. Hey, it was supposed to be capital W and I wrote lowercase w. Can I get credit for it? Or I know it said 5 decimal points, but I put 4 decimal points. I mean, it's right. I can see that it's right. So just tell me. Now, let's go into Desmos and let's put this data in and see if we can come up with a good regression line. In Desmos, let me clear what I have here.
What question is that again?
Let's see, this is number,
I asked that question, right?
yes.
I just don't know. I can't find
It's
it.
3-4, example 023.
Yeah, just I'm the one that put the question mark for that one.
Oh, did you get, you good on it?
No. I would like to go over that if that's okay.
Yes, of course. Yeah, this one is numbered exercise 023.
Yeah.
MI.
All right.
All right, so we can go in and check out Desmos. I'm clearing everything out of here, right? And I like to click home to bring the origin back to the middle of the screen. And I'm going to go into this new cell and I'm going to add a table by pressing the plus sign. And now I have the table. Now I'm going to put in the data from here. And as you can see, they're a little bit ugly. So just be very careful and delicate with them. Make sure you put the numbers in exactly correct. The first number I see is 6. Next number I see there is 11.1. Next number I see there is 13.7. Then I have 14.9. And then you have 17.6. Now in the Y column, 1.8 and 3.2. And then 3.7 and 4.3. And then 5.2. Okay, it looks good to me. I don't have the data in. Let's get a look at it. Looks like it goes 6 to 17.6. Let me just zoom out a little bit. Yeah, that's good enough. I could see them now. Let's get that line. Go and click a new cell. And then in that cell, we're going to type the syntax relating the variables y1 and x1 by saying y1 and then is similar to m, the parameter for slope, times x1 plus b, the parameter for the intercept. And now I have new values for those according to this regression line. The slope is given here and the intercept is given here. I'm going to write it using the tool in Zoom. It should look like this. Y equals, now remember, you want 5 spaces. You want 5 decimal places. So carefully take out and round appropriately to get those parameters in the structure of y equals mx plus b. It would look like this. I hope that makes sense. I rounded them to 5 places. I inserted the M value where it goes, and I inserted the B value where it goes. Take a look at the answer from WebAssign. See it right here. I'll highlight it. On the nose, exactly. So if you're careful with rounding and the 5 decimal places and whatever they want, you'll get it right. Next piece of the question says, which, and I can get rid of that stuff now, which sample might be considered to have a lower rice weight than expected from the whole crop weight? Now, we have some points that we can put in there and think about. Now, notice these points are actually the points from the story. They're all right here. Look, here it is, 6.1.8 is this one, isn't it? Yeah. And then 11.1, 3.2, there it is. So this is just a copy of this table if you look at this. What they're trying to say is which of these points is lower than it's supposed to be? That's a good question. And we answered that question before. Remember when we measured before the dot that was the lowest below the line? That's what the question is. It's a very good application. Which of them should it be? Well, let's take a look at our, oops, I didn't do that. Let's take a look at our graph again. In the graph, and I'm going to have to zoom in a little bit for this. Let me drag it over here. I can see that this green dot right here, I'm going to use the tool. This green dot right here, there you go. You think you can see there? Is that not the one that's the lowest below? It is the third in the row, and that's why the answer is, what is that dot, by the way? Here it is. It's 13.7, 3.7, right? That's the answer we want. Right here. Okay. That's how you do part B. Right, let's look at part C now. So, how much additional rice weight can be expected from 1 ton per hectare of additional whole crop weight? Round your answer to 2 decimal places. That word is not hectare, I'm sorry, that's hectare. Hectare is a different measurement. Hectare is something else. So it's hectare. That's not really that important. But what do they mean here? Well, what do they mean 1 ton? How much additional rice weight can be expected from 1 ton? Now, this is in disguise that marginal slope lesson again. Like how much of an increase in money would it be in 1 year? How much of increase in weight would it be for 1 ton, right? Because remember, the X value is the crop weight in tons. The rice weight is B, which changes according to whatever W is. So one way to look at that to see it is if you had data that was 1, 2, 3, 4, 5, 6, 7, it would be easier because the numbers would go up in a nice sequence on the right. But since this data is 6, then weird numbers like 11.1 of them, 13.7. If you had data that was perfectly linear in order, it would be more clear that every time that you bump up only 1 unit on X, you bump up a certain quantity on Y. And that's what this question is about. That margin is how much you would bump up because of just an increase of 1, you know? And the answer is, as you could see, 0.29 to 2 decimal places, because what is the slope of this line? Look, you remember what the slope was. It's the coefficient of capital W. It's 0.29. So to go 1 more in X, the quantity or margin inflates by whatever the slope is. That's why the slope is M equals. It's a margin. That's how you do that question. I hope that was helpful. There is another one below. Let's look at the next one. There's another one right here. Similar. Oh, I think we did this one, right? Did we? Yeah, we did this one already, so we don't have to do that again. I think there's another one down here, though. Let me see. This is a new one. All right, let's go through and do this one. It says, a stream that feeds a lake is flooding, and during this flooding period, the depth of water in the lake is increasing. The actual depth of the water at a certain point in the lake is given by a linear function, and then we have a function given there. Your T is measured in hours since the flooding began. A hydrologist does not have this function available and is trying to determine experimentally how the water level is rising. She sits in a boat and each half hour drops a weighted line into the water to measure the depth to the bottom. The motion of the boat and the waves at the surface make exact measurement impossible. Her compiled data are given in this following table. part 1, please plot the data points. Now, if you want to plot data points, when you go to Desmos, as soon as you put data in, before you even try to do a regression line, points appear. So all you have to do is start the process and you'll have an image of all the points. So let's do that first. I'm going to go back to Desmos. Here we go. And I'm going to go home to the origin and I'm going to clear out these different cells. And now I'm going to insert a table with data like this. And let's go and get them. Remember, be careful, do them one by one. The first one, well, actually, in this case, I think I can kind of jump because the first group of them on the left is pretty easy. It's 0 through 2 with increments of 0.5. So I think I can handle that. That would be 0, 0.5, 1, 1.5. Oh, look, and Desmos knows what I'm doing. There it is. All done. How about the Y values? Let's put them in. I have 51.7, 52.7, 52.7. Then we see 53.2 and 53.8. Now, if I want to get a good image of these dots, I can zoom in or zoom out. But remember, you're supposed to try to match them along with an image. It's kind of funny. They look like they're bunched there, but I'm going to have to change the wrench. Before I do it, though, let me look at what they want. They're looking at it this way. Take a look. Let me zoom out so I get a good picture of it. Hold on. Here we go. So I think you could a little bit more zoom out. There we go. That's a little bit better. That's too small. There we go. All right, so I think you could see, let's get our drawing tool. Our X values are going from 50 to 51. What? 50 to 55, aren't they? 50 to 55 is what the Y-axis does. Kind of curious, but that's what they want. And then along the Y-axis, they want 0 to 2. All right. So see what I'm doing, guys? I'm just investigating the labels to see what they want for this picture. For Y, 50 to 55. Let me put that up there. And for X, it looks like it's going to be 0 to 2. So I hope that that's clear, because you're not going to get these questions right unless you very carefully change the axes accordingly. So again, Y is from 50 to 55. X is from 0 to 2. In the wrench, Y was 0 to 55, and X was 0 to 2. No, Y was 50 to 55, wasn't it? Yes, it was. All right, now look at it. Look at the image. I think I can compare it. If you want, you could zoom out a little bit. It might make it a little bit more clear. But this is what we're looking for. Now, which of these look like that? All right, let's see. This is kind of like if I was going to draw, it would feel kind of like this. You know? And thinking of that idea, it kind of looks like it's either going to be this one or this one. Because I don't like how over here, this is all the way up here. That's too high. And I don't like the way that this kind of like goes up to, this is too high up here, these dots to me. That's why I feel like it's one or the other. Now, the next thing I could do to check is I notice that right here, and you have to look really, really close at things like this, but it's on the intercept that it gives it away. Right here, it looks like it's between 51 and 52. And right here, it looks like it's between 50 and 51. You'd never be able to see that unless you had the correct zooming in or the correct wrench view. So you have to really look very closely for that kind of stuff. Let's see where the dot is on the actual x-axis then. And as you can see on the actual x-axis, here it is. It's between 50, right? Isn't 51 right here? So it's between 51 and 52. It tells you that it's between 51 and 52. So that being said, if it's between 51 and 52, that means I'm going to go with this one here, right? Because that's between 51 and 52. And the other one was not between 51 and 52, it was between 50 and 51. So you have to look that close, guys. You have to look that close at these graphs and at this data. That's what you're learning about in math models, is to look closely enough at data to make that critical decision. Should it be this graph or that? You know? All right, so that's that question. Let's take a look at the rest of this case. Okay, we have some more in here. Now it says find the equation of the regression line. Of course, that was coming. You knew that was coming. So let's type in the syntax. Y1 is similar to mx1 plus b. And I have values of 0.94 and 51.88. And there they are, 0.94 and 51.88, just like we thought it would. There it is. And now it says explain in practical terms the meaning of the slope. Again, like I showed you, it's a fill in the blank structure, once again demonstrating the concept of the margin and the slope. So explain the slope of 0.94 foot per hour means that the floodwaters are rising by 0.94 foot each 1 hour. Right. Okay, there you go. So you have that. And again, to reiterate that application, which is so very important in business and quantitative analysis, we really do that a lot in quantitative analysis. And then we have add the regression line to the plot of the points, which is already done for you by Desmos. There it is. So you can use that and carefully measure against which one is which again. And that's actually really not hard to do at all. In fact, I can see right now which one it is, just because I know that the intercept is between the 51 and 52. And I also know the slope of it, it's got to be this one here. Yeah, it's this one here. So we're going to say it's that one right there. And that's because I see the point that I remember between 51 and 52. And I also feel like this is a correct kind of steepness. If you look at how steep that is, you know, it's the same steepness that I see right here. Oh, well, the reason why it's not actually is because I zoomed out a tiny bit. If I zoom in, it should work, or zoom out, like there's something missing in it, but it's similar to it. And then last but not least, add the graph of the depth function and graph it in red and put it with it. Now that's not hard to do. See how it says D equals? You're just going to put it as y equals in there. So y equals 0.8x plus 52 right here in a new window. Y equals 0.8x plus 52. Is that what it was? Plus 52? Let me see. Yeah. All right. So now we could see what that looks like in there with it. And you can use, you know, your wrench to make sure you have a good view and compare and contrast very closely once again, and make sure that it fits in there where it's supposed to. It looks like the red line is a little bit below on the left, a little bit above on the right. That's a deciding factor. That's why I know it would never be this one. And I know that it could not be this one, because you see how the red is above the black line in both of those? That's why it couldn't be either of those. You have to do things like that to weed out which ones are and which ones aren't when it comes to graph multiple choice. Down here, you have a similar situation. Things like we have something a little bit off there. Look at that again. Should be below 0.8x plus 52. It looks like it's not going correctly. Oh, yes, I see what it is. Okay, sorry, let's backtrack for a minute. In here, look at the black line and the red line here. In this one, it's inverted. This is black, this is red. I don't know if you can even change them or if it matters, but this one's supposed to be the red line. Sorry, this one's supposed to be the black line. So just watch out for that. I should have made mention of that. Desmos picks random colors when you put a new thing. They go put a new thing, who knows what it'll be. See, they made it red. Like when you put in something new, there's no rhyme or reason to what color comes up. Anyway, if it was like this instead, then we could use that as a guide, thinking of them inverted. And it does look like the red line should be going through 52. Like I see that right here. If I look really close, doesn't it look like the red line? Remember, our black line is their red line. So if you look at that black line, it's going right through 52 there. I would use that as part of my reasoning. And here I have that going on. Actually, right here I have that going on. Goes right through 52 right there. It does not go through 52 in this one. Right? Let's take a look at the ones down below. Here it goes through 52. But it looks like a wider X than I was expecting, and that's why the top one is better. And here it does not go through 52, go through 51. So that's how you can weed out and come to the final conclusion that it is, after all, the first case here. All right. And then a couple more questions. Does it appear that the hydrologist was able to use her data to make a close approximation of the depth function? And the answer is certainly. The data does give a close approximation. In other words, look how very close the dots are to the line in the situation. Now, in other words, remember, guys, I'm looking at this graph only because the other ones are incorrect. But if you look at this one graph, you'll see the actual equation, which is the red, which she should have used, was very close to the line of best fit that came about from her raw data, gathering her raw data. So that's why we can say yes. Look, in other words, they're almost the same line, aren't they? That's why you can say that way. All right. And what was the actual depth of the water in T equals 3 hours? Something like that. The actual depth of the water is the answer to the actual black line. In our case, the actual red line. So at 3 hours, 3 hours is actually all the way out here. We could zoom out a little bit to see 3 hours a little bit better. But 3 hours, I'm going to draw a line. See the 3 right here? This is 3. 3 hours is right here. So what was the actual depth? It was somewhere between 54 and 55 is what we're going to say for that question. 54.4 is the answer, as you could see. And if you want, you could find that exactly by taking the answer of 3, T equals 3, and putting it directly into the original formula, which is up here, that you got the answer right. Here it is. So if you put that 3 into this formula, put 3 in there, it will give you the answer of 14.4, like we, or whatever it was, 0.4. Was it 14.4? Uh, 54.4, that's what I meant to say, but I think you guys understood. In other words, that number comes up by putting 3 into that equation up there. Then, what prediction would the hydrologist regression line give for the depth of water at T equals 3 hours? And round your answer, and it's 54.7. And that would be what would happen if the hydrologist line is being used versus the original line. So this number, 54,400, you'll get if you put T into this formula right here. The formula that was given all the way in the beginning, which is right here. That's if you put 3 in there. And if you put 3 in the regression line formula, which is this, then you'll get the other value. Just to reiterate, look at the answers and you'll see what I mean. This one is saying what is the actual depth? That's using the formula that was given. This one is saying what would the hydrologist regression line give? That's using the formula you found. As you can see, the answer is almost the same, which is another indicator that the hydrologist was making accurate predictions. Okay, see if there's any other questions for my students up here to answer. Let me see. Looks like they've all been answered. That's good. We do have one here. Let's take a look at this one. Again, find the equation, the regression line. Okay, let's put this data in and see what we get. Why did that happen that way? Let's see. And come home, put in a new table. Okay. Let T be the number of years since 2010. That alone might have really thrown your whole equation off, actually. Look at what it says right here. Let T be the number of years since 2010. What that means is that this is actually a 0. This is a 1. This is the 2. And this is a 3. And if you put in 2010, you might get a very, very large slope like 0.58 or something. It looks like you're actually pretty close. Oh, but that's probably why you have a very large intercept of that. That's probably why that's like that. If you put in the numbers 0, 1, 2, and 3 instead of 2010 through, you should get it right. Let's just do it as an exercise anyway. So first in Desmos in the X, I'm going to put 0, 1, and look, Desmos knows what I'm talking about, so it just keeps going. You can keep going and going as far as you need. The Y values in there are going to turn out to be 15.0, 15.5, and 16.2 and 16.7. Now, let me get rid of my rectangle and my stuff here. All right, let's figure out now the equation of the regression line. First of all, I can't see it, but I don't care yet because I'm not trying to look at the graph yet. I just want the equation of the line. And I'll write in y1 is similar to mx1 plus b. And there's the equation of the line using 0.58 for m and 14.98 for b. And there you have it. 0.58 for M and 14.98 for B. Probably because of using the entire year. That's a common mistake. The next thing says explain the meaning of the slope, which you would have had correct. If you wrote this as your formula and you had this as your slope, then that number does belong here. But the correct answer was actually this. So that's what we should have got there. No big deal. I think we're going to stop there because I think you know how to do the rest of the stuff. It would be a matter of carefully plotting it and putting it in where it goes. This time it should be B. And then also what happens when you put 17.3 in? Yeah, the actual gross national product is accurate. So I would put in 17.3 in, and remember it is already in trillions of dollars. See, it says gross national product, and it says it's in trillions of dollars. So you can actually act like the word trillion is not even there. You could just call it even dollars. It's like the same idea. The wording, like if you hear the word million, or even sometimes in WebAssign with math models, they say the word thousands, which is, 4.2 thousands is 4,200, but we know that, but they do things like that to align data so that it's easier to look at things on graphs. That's the point of all that. Anyway, that means you can ignore trillion and not use 15 trillion, but use 15.0 as your value in it. And going through that, if you put that number in there, 17.3, into the formula that you have right here, you're going to get your solution to that question. All right, so that's what I've got for you guys. Let's see if there's anything else in there that we had a question about. See? This one looks like it's done. Come on, the answer. This one is good. Good, good. This one looks like it's good. We'll move that to answered. And see, we did talk about this one. Yes, we have this one. Just missing that one last one. It's 54.4 is what goes in there for that last one. It's 3.4 example of 15. The bottom there is going to be 54.4 because we did go through that one. That's all we got, right? Yep. Yep. Yep, he's done with that too.
Mr. Marquetta, thank you very much.
You're
I
more than
appreciate
welcome.
it.
Looks like we got all the questions answered. Yep, we're clear. Okay, so if anything else, let me know if you need any help, and good luck on your exam. It's Thursday, and then we'll see you guys in class on Monday next week, okay?
Thank you. Have a good one.
You're welcome. Bye-bye, guys. Have a good one.
Thank you. Have a good one. Thank you for all your help.
Anytime.
I have a question though about the test.
Most definitely.
The test is Thursday, right?
Yes, that's right. It's going to be on Thursday. It'll open up at 1 o'clock for you guys. And I'll leave it open over there until 5 o'clock for people that might be needing to start a little late for whatever reason. But
Yeah.
you'll have an hour and 20 minutes to take it. But you really have 2 hours. You really have 2 hours to take it. I made it 120 minutes. just in
Oh,
case you need
so we have
more.
2 hours to take it, you said?
Yeah, it's like 2 hours to take it.
All right, cool. Also with the WebAssign, when can I like get it to you by? Like the WebAssign, both of
The,
them.
the WebAssign, just if you can get it completed and have 90% of it done, then you'll get a check mark that it's completed. You just have to get 90% of it complete and then leave it.
All right, so like I could get it done by like Thursday.
Sure. I think I extended. Did you do a request?
Oh no, I didn't request. I was meaning to email you, that I wasn't gonna be able to get it done this past weekend.
Okay.
So but I can
Open
get
it
it
up
done.
right now for me and send a request. I'll approve it right now, and you can have till Sunday to do it.
Oh, okay, this coming Sunday.
Yeah, that's enough time, right?
Yeah, no, that's good. That's good. All right, yeah, I'll request right now for
All right,
extension.
sounds good. Send a request. I'll let it in, and then if you have any questions about it, we can talk again, or
All right,
we'll
cool.
talk in class or whatever. All right.
All right, that sounds good. Thank you.
You're more than welcome, and I hope you have a beautiful day.
You too.
All right, bye, Tom.
Bye.